Okay, guys, our today's topic is sorting and searching. In today's world, and if we think about ourselves, then you will see that each time, or we can say most of the time, we search something on internet, on books, in the index page like this. So searching, we search different kinds of things. So in internet, if we think about this, then there might be millions of items of stored data, and searching for information would be very efficient if the data was not sorted. Sorted means data will be decorated in alphabetical order or in some meaning of names, like according to some rules. Then it will be easy for us to find out something easily. Okay, think, suppose I have given you a dictionary which is not sorted. I have given you a word that you have to find out this word in this dictionary. Then how difficult will you feel? How difficulty will you feel? It will be very much difficult if the dictionary is not sorted in an alphabetical order. So in computer programming, two of the most common tasks in computer programs are sorting data into a particular order and searching for particular items of information. So sorting and searching algorithm. There are many algorithms for sorting and
Assalamu
searching.
alaikum, sir.
Walaikum assalam wa rahmatullahi wa barakatuh. So there are many algorithms for sorting and searching information. Along them, if we talk about sorting, then two algorithms are used mostly. These are bubble sort and merge sort. We know that there are many kinds of algorithms, or you can also create some algorithms for searching or sorting. But comparing all of them, these two algorithms are most efficient, popular, and easy. Okay, then searching, there are also many algorithms for searching information. So along them, linear search and binary search, they are most popular and efficient, and they are easy. So we will talk about these two sorting algorithms and two searching algorithms. And after learning this one, you can explain how the choice of algorithm is influenced by the data structure and data values, and evaluate the fitness for purpose of algorithm in meeting specified requirements. Like if somebody has given some task to you, you have to work on it, and there are also some okay there are also some criteria, or there have some search box, and you have to input or include some search box in that program. So how can we evaluate, how can we choose what kind of sorting will you use for this program? Actually, it will depend on the data structure and data values. And if you work on it, then you will able to find out, or you will able to find the fitness for the purpose of algorithm by analyzing the requirements and specified data. Okay, so we are oftenly calling sorting and searching, sorting and searching. So what to search or sort, and where to sort or search. What to sort or search. Actually, in computer program, or in computer world, or we can say in computer science, we will sort or search data or information, or we can say value. And where to sort or search, we know that all of the data, all of the information are stored, right? So we have to search this data in the computer memory, but these data are stored in computer memory in sort of array. Array means like table or list of data. So we have to search or sort data in array. So now is the question again. I'm thinking that you might ask the question, what is an array, right? So an array, an organized collection of related values that share a single identifier. Here you might also ask, what is identifier, sir? We have already read this one in the first semester at the beginning of this book. What is identifier? We know that in computer memory, a computer program creates some variables, right? So a computer program uniquely identifies some sorts of variable or memory or location in computer memory by using a unique name, right? So this unique name is called identifier. If you consider this program, like say enter first name to display, and then receive first name from the keyboard. So in second line, the first name, receive first name. First name is the identifier. When this program will run, this identifier will create this identifier will create some space or allocate some space or some variable inside the computer memory. Are you clear?
Yes, sir.
Okay.
Yes, sir.
Here is the again I'm repeating the definition of array. An array is an organized collection of related values that share a single identifier. Okay, now we know what is identifier, but here says the related values share a single identifier. Okay, let's see. So this is the definition. Now we have already solved some programs. We have written some pseudocodes. So when we want to allocate some variable or we want to assign some values inside the program, that time we must have to declare a variable, right? Like this, set is to 15. Is a variable, and the name is identifier, and it will create a space or a variable inside the computer memory, and it will put 15 on this memory or in this memory. Again, here set first name to notion. So first name is an identifier. It will create variable inside the computer memory, and it will put the name notion inside this computer memory. So in both of these cases, we are watching that the identifiers declares a variable and putting the single value like 15, notion. These are the single values they are putting inside the memory. But what if a program wants to store a lot of related values, such as the name of a group of friends? Okay, this is the tedious way. So if we follow this tedious way, then we have to program like this way, like set friend 1 to Ayman, friend 2 to Meta, friend 3 to Onik, like this way. So the programmer will feel difficulties because in each case they have to declare identifier, and it will create variable inside the computer memory, and inside this computer memory they will write the single values. But what if what if we combine all of the name inside the single identifier? Exactly, the array with identifier, it can provide us this opportunity. It allows us to store multiples of same values inside the same identifier. Like this way, like array friend, this is the identifier. It will create a variable inside the computer memory, and it will store all of the friends name inside the single identifier or single variable. So here like inside the array friend, this is the identifier, and inside this variable it will store Ayman, Onik, Meda, Rumali, upon like this, all of the friends name inside this single identifier. So this is the definition of array: an organized collection of related values that shares a single identifier. Like Ayman, it also shares the array friend. Onik, it shares array friend. Meda shares array friend. Rumali shares array friends. Upon shares array friend, this identifier. All of them are representing the same identifier, right? This is the array, and it could store related data and their shares the same identifier. But one condition is here: One condition is that, so inside the array friend, all the related data will have index number. Like Iman, its index number 0, Onik index number 1, Medha 2, Romali 3, Apun 4. So all of them has an index number. So according to the index number, they will take place inside the computer memory. So if I represent like this way, then it will be easy for you to understand that this is the index number at the left side, and this index number represent the data value inside the array. So this is the very much easy way. If you want to add any other name, like say array friend 5 to Emma, that means in the fifth position of this array, the name Emma will be added. And then set array friend 6 to Tanya. That means in the sixth position or in index number 6, the friend Tanya will be stored. So every element inside the array has an index number. By using these one, we can represent the values, or we can represent all of the elements inside the array. We can add, we can delete by using this index number. Okay, so our main thing was sorting and searching here, bubble sort. So now we will talk about bubble sort. Sorting means arranging data in an ascending or descending order. So there are many kinds of algorithms. Beside them, bubble sort is also the most popular. Bubble sort algorithm. What is bubble sort algorithm and how it works? The bubble sort algorithm works like in array. It will start from one end and it will compare the values and it sort the values, and it ends at the end of the array. So it start from one side and end in another side, and finally it sorted all of the data. So we can say again, the bubble sort algorithm start at one end of the list. Array means a list of data, a list. So here it says the bubble sort algorithm start at one end of the list and compares pairs of data items. If they are in the wrong order, they are swapped. The comparison of pairs continue to the end of the list. Each complete traversal, each complete traversal of the list being called pass. This process is repeated until there have been no swap during the pass. So what does it mean? What does traversal mean? Traversal means travel across or through something. In an array, if we think we are talking about array, so if you consider this one, then we can say an array can be traversed by moving from the first to the last element in order to examine that data sorted at each index position. So this is the bubble sort algorithm. Here says start at the beginning of the list. That means at the beginning of the array, compare the value in position 1 and 2. Yes, again, I'm telling about bubble sort that it will compare two values and it will go ahead. So if it get any unordered inside the values, then it will order, it will swap. Swap means it will exchange value. So that means, sorry, it will exchange the position of that value. So again, compare the values in the position 1 and position 2 in the list. If they are not in ascending order, we are thinking about ascending order, then swap them. Compare the values in position 2 and 3 in the list and swap if necessary. Continue, next step, continue to the end of the list. If there have been any swap, repeat step 1 to 4. So until the data is swapped, we will continue swapping. And finally, when we will get no swap, that time we will understand that the data has been sorted. Okay, I want to give an example to you that we have a list of data like 4, 2, 6, 1, 3. Now we want to sort this data. We want to sort this data in ascending order. In ascending order. So according to the bubble sort algorithm, first it will compare the first position and the second position values. So are they in ascending order? No, because 4 is bigger than 2. So according to the ascending order, the less value or the less number will be first and the greater value will be the last. So we are watching that they are not sorted or they are not in ascending order. So what we will do? They will swap. Swap means they will exchange their position. The 4 will go to the next and to return back to the first position. And finally we'll get like this list. Right? And then the next comparison. Now the position 2 and 3. The values 4 and 6. Position 2 and 3. So are they sorted in ascending order? Yeah, they are sorted. Okay, so we do not have need to swap. Okay, then next compare position 3 and 4. Are they sorted? No. So exchange or swap value. So they are swapping their position and we are getting like this way. And then the position 4 and 5. They will compare each other and they will they will compare, are they sorted or are they in ascending order?
They're gonna swap as well.
Yeah, so they are not, so they will also exchange their position. I will get this one. So in this way, from the in a list from the first to last, when we will traverse at the first time, we will call this first pass. We will call them first pass. So in this first pass, our
Wait,
all
pass. What? What did
yes
you
yes
say? Like, what did you say? Pass, or
pass one. Pass means it already has been travel from the first element or first position to last position. The program or the algorithm travels from the first position to the last position of the list, but we are watching that these lists are not sorted yet, are not in ascending order. So it will
Yeah.
start the second pass. So in second pass, so we got the data in this situation. Now again, the data will start comparing from the first of the list. So it will compare both of these two. Are they sorted? Yes, they are sorted. So first position and second position. Okay, it's done. Then next position, second and third position, they will compare each other. Yeah, they are not in ascending order. So they will swap and they will sort it. And then next position 3 and 4, they are sorted. No. Okay, then they will also swap. Okay, now we'll compare the fifth and sixth position, sorry, fourth and fifth position. Oh, they are sorted. Okay, two, pass two already has been completed, but these lists are not in ascending order yet. Okay, then it will start the third pass next.
The pass 3.
Yeah, pass three. In pass three, again it will compare from the first of this list. So two, position one and two, they are comparing, they are sorted. No, swap
Swap.
and got the value. Now this
Oh,
is,
now it started.
and finally we are getting the sorted data. Understand?
Yes,
Yes,
sir.
sir.
Ah,
Yes, sir.
so pass three has been completed. So we are in this human neuron. We are watching that in this three pass, the list already has been sorted, but the computer needs the next pass also, the fourth pass also, because we are watching here in this bubble sort, it will repeat the swap until it will find any swap. That means if it didn't any swap in the list, then it will finished or it will give up. It is updated. Okay. Okay then. So we have already